Welcome to the session. In this session, we will discuss about the problem when we are having the two separate model for vehicle and electric motor. So now we have developed the electric motor model for the 5 HP DC motor that we are having. In this canvas, I have put both the model of motor and vehicle together. This is vehicle having the 200 kg mass and radius is 0.279 radius of tire. So what is the problem if we want to predict the performance of how motor will perform when it is connected to the electric vehicle? That means the torque developed by the motor should run the vehicle, and vehicle should affect if vehicle torque should reduce the speed of the electric motor. So it should be considered as the load. So vehicle should act as a load to the motor. But what's happening here in this motor of the DC motor, the load torque is the input quantity. So we need to apply the load torque, that is opposing torque to the torque developed. So this signal is the torque developed by the motor. And in vehicle model, the torque is the input. So here also torque input, here also torque input. So we want this torque developed by the motor should run the vehicle, right? But what will happen if we connect this torque line to this point? So this will not have the feedback effect, because the motor rotor inertia will remain the inertia of only shaft, and which remains very low. So this shaft and this rotor will certainly get the high speed, and this torque will act as only the measurement quantity which will supply to this vehicle model, and this vehicle model will give the output according to this measured torque, but it will not give the actual speed of the vehicle and speed of the motor on varying the supply. So this is one thing. So what first I will do, I am removing this slider gain. So whatever input torque, and using the subsystem I am making the, and beta is also incline angle. So let's make a subsystem for this, selecting this area. So we are having two input and one output. Right click, create the subsystem. So here our subsystem is ready for the vehicle. I will name it according to, so we can save it and store it. Vehicle having 200 kg mass and 0.79279 is the radius. So we can remember, and this line I will change to, this is the torque, this is the angle beta, incline angle, and here output is the speed in meter per second. This block will give the speed in meter per second. So to understand the problem, we are having the same issue, that we need to build the model together for the motor as well as the vehicle. So all mathematical equation should be designed such that it's include both the model in one simulation model, then it is fine. But if we are having two separate model, then we need to go for the passive loading scheme. So in next session we will discuss the passive loading scheme, how we can load this vehicle model to the motor, and how we can predict the performance of how this motor will perform for our selected vehicle model.